welcome guys. In this video, let's talk about another pi algorithm or the pi series called the Wallis Product. Okay, let's just write down the results and give the proof. So pi over 2 can be described as n from 1 to infinity product for n squared for n minus 1. So for n squared minus 1. Okay, another expression which is stupid is that you just write that's 2n minus 1 times 2n plus 1. Okay, so the first term is 2 divided by 1, 2 divided by 3 times 4 divided by 3 times 4 divided by 5. So this is these two, and then the next will be 6 divided by 5, 6 divided by 7, and keep going. So 8 divided by 7, 9 divided by 7. Okay. Oh, sorry, 9 divided by 8. 8 divided by 9, okay. Yeah, okay. So, let's give the proof. Okay, so proof. Okay, so we will have two methods. So remember that, you can check out my video list. Basically, there are various algorithms computing pi. So maybe the most easy one is the so-called Leibniz formula. Okay, so which I will leave the proof here. So I will leave the proof in the comment. So you can check out. So this is the Leibniz formula. Okay, so before I keep going, subscribe to my channel. Okay. So but now we talk about Wallis Product. Okay, so this is another way. Yeah. So that's the first. Let's see what I intended to do. Okay. So maybe the quickest way we are using is using the infinite product of the sine function. Okay, so remember that the sine divided by x, sine x divided by x can be written as using a Taylor expansion, right? So everybody knows about this. Okay. And if you try to write as a infinite product, then you know that this function contains the pole, contains the 0 when x equals to plus or minus n pi. So from 1 to 2, keep going. Right, so this can be written as 1 from infinity, 1 minus x squared divided by n pi squared. Okay, so this is the quickest way to prove it. So once we have this, right, let's just let x equals to pi divided by 2. So right hand side become 2 divided by pi, and the left hand side become the left hand side is 2 divided by pi. The right hand side is from 1 to infinity, 1 minus let's say pi square, 4 square pi square. So we can delete this pi square. Okay, so and then we get an answer, right? So just finally. Okay, so this is the quickest way to prove. Okay, so do not waste your guys' time. Again, okay, so this way is the first way. Okay, then the second way usually is very much rigorous. It's so-called using the integration of 0 from pi sine nx dx. Okay, so you can check out my video channel. I will leave the link below. Basically, the reduction formula for this in. So I don't want to waste the time to prove it because I already proved it. Okay, so the result is that in. Oh, I will leave the reduction formula for this in the comment so you can check. You can check the in divided by in minus 1 will be n minus 1 divided by n. So you can check it, change it to to n minus 1 divided by 2n plus 1. Become 2n plus 1 divided by 2n. And then you can easily check that I0. What is I0? Let's see. Okay, so I0 is n equals 0, which is just pi, right? And then you can check out I1, which is 2. Okay, so you can use this formula to get this induction to get your I to n, which is 2n minus 1 divided by 2n, 2n minus 3 divided by 2n minus 1, keep going, keep going. Okay, so once you keep going, then let me see. Okay, keep going, right? Okay, until you get half and I0. So use this, right? Finally, you get I to n will become pi times k from 1 to n 2k minus 1 divided by 2k. Just keep using the reduction formula, okay? And then the same reason is that you can check that I2n plus 1 will become 2k from 1 to n 2k divided by 2k plus 1. Okay, so you will have these two. Okay, so now one can use the so-called squeeze theorem. So remember that the sine 2nx will less or equal to sine 2n minus 1x, and greater or equal to sine 2n plus 1x. When x is positive, in 0 to pi, so that side will be positive. So this tells you that I2n plus 1 will less or equal to I2n, and then less or equal to I2n minus 1. Okay, so once you have this, then everything will be easy. You just let me scroll. Let's see. Okay, so let's go here. So you can see that 1 divided by 1 less or equal to I2n plus 1. We just divided by I2n plus 1, and I2n minus 1, I2n plus 1. So this guy will be this guy is from here. So it's less or equal to 2n plus 1 to n. So by the squeeze theorem, if n goes to infinity, then right hand side is 1, right? So it means that n goes to infinity, I2n divided by I2n plus 1 should approach to 1. Okay. So you can take these two, divide it, so you get a limit n from 1 to n to infinity, pi divided by 2 times k from 1 to n, 2k minus 1, 2k. Sorry, I'm stupid. You just use this divided it, so you pi divided by 2, k from 1 to n, 2k minus 1 divided by 2k, and then divided 2k divided by 2k plus 1. So you get which is 1. So you get pi over 2, which is just the product k from 1 to infinity. You just take it into infinity to the right hand side. Okay, so it's 4k squared divided by 4k squared minus 1. Okay, so this is a proof. And so the missing part I didn't show here because I think it's very tedious is that prove this idea. So I will leave the proof. Since I already proved the reduction formula, I will leave the proof in the link in the below so you can check. Okay, see you guys in the next videos. So next time we will give more amazing pi approximation.